Thank you, Miyoshi-san. So I'm Hirofumi Tomita, the team leader of climate science, also meteorology science. The title of my talk is current status of a scale and its future toward the accurate numerical weather prediction. And our team has a responsibility to develop a good model in the big data assimilation project, driving Miyoshi-san. So this is my talk. So first, I briefly introduce the scale, our regional model. And my main talk is on the progress of model development during the BDA project. And also, after that, I would like to mention the modeling issue for high resolution endeavor P. And finally, I will indicate the future direction. Okay. So scale is include not only the model, but also a library, a physical library. And scale means the scalable computing for advanced library and environment. And this is available from usual PCs to supercomputer like K. And also, this library is constructed collaborating with the computer scientists in our institute. And this model open source with the two closed BSD license, and the website is here. And scale has several concepts. So first one is to cover many model components with unified API for comprehensiveness. And the second is enhancement of enough documentation for traceability. And also, we prepared a lot of test cases for model validation. And so finally, final point is very important, pre- and post-processing tool for user usability. Okay. So this is the main talk, my main talk. So first one is the, so we developed a new nesting framework, so-called cost-effective online nesting procedure. So motivation is on the computational problem in conventional method. So conventional nesting method calculates that child domain is conducted after that of parent domain. So this is sequential way. But theoretically, we can overlap that. So CONEP, our framework, overlap the calculation of parent domain to child domain. For example, so child domain calculation is conducted together with the preceding simulation of parent domain. As a result, so child domain calculation is running without waiting of parent domain calculation. So this is far away. So this table shows the performance experiment on the K computer. So we can see our model framework, CONEP, faster than the conventional method, about the 20% and or 30%. Okay. And also, secondary is a change of double precision to the single precision for strong scaling. Okay. So left show the weak scaling, right is the strong scaling. So we can see we get about so almost 100% weak scaling up to full system. But strong scale also indicate a good performance. However, there is some bottleneck by memory bandwidth owing to the dynamics. Okay. So to get a much higher strong scale, the single precision was employed with enough validation of physical performance. And this theoretical discussion is now submitted to the James. Okay. And the third is improvement of surface Frak scheme. And the problem is associated with the inconsistency between a finite volume method and conventional surface Frak scheme. And in general, finite volume method represents the volume average value. But C surface Frak scheme assumes the value as the center point on the some Money-Uphoff profile. Okay. And this gap leads to underestimation theoretically. So we reformulate the frictional velocity and the potential temperature suitable to finite volume method. So this picture shows the estimated surface flux in unstable PBL simulations. So you can see this line shows the new method, and this line shows the conventional method. And you can see the conventional method has underestimation bias of surface flux. If the resolution increases, the bias becomes large. But if we consider the physical profile, the bias is much improved. And this is very, very promising because the new method has a better convergence like this against the vertical resolution. Okay. So fourthly, the effect of aspect ratio of group spacing in LES. This indicates the importance of appropriate filter length and consideration of group aspect ratio. So motivation and purpose here. So how is mixing length set, and how difference between the case of consideration of non-consideration for aspect ratio of group spacing. Okay, and this is figure show the so effect of consideration of aspect ratio. And so if we consider the aspect ratio, so if we don't consider the aspect ratio of grid spacing, we can see in the inertial sub-range, energy parting occurs. But if we consider the aspect ratio, the result much improves like that. So as conclusion, we should set an appropriate filter length according to the numerical scheme. So this scheme depends on the so advection scheme. So, and so important point is express consideration of aspect ratio improves the energy spectra like this. Okay, the second part is scientific achievement. Okay. So the first one is back building score line simulation and its maintenance mechanism. So you know, successive thunderstorm in the same area bring the serious damage by a landslide. In Japan, back building type score line is often observed. So we conducted a case study so for understanding of its mechanism. And this picture shows the specific humidity and temperature at the upper boundary layer. So green contour shows the heavy rainfall region, and new convection cell BBS was generated within this circle, this yellow circle. And in this zone, both cold front and moist town exist, you know. So this paper, conclusion of this paper is here. Cold front forced ascent of air, okay, and the local moist town makes the moist convection be active. At this point, the newly generated convection cell onset continuously. So a new finding is that the water vapor front, so such as a local moist town, is more important than the cold air on the front in this case. Okay. And the second second achievement is the development of a new downscaling procedure for regional climate. And the basic idea is to divide the GCM results, some components One is the climatology as a mean state. So, for example, this is a monthly mean atmospheric state. And the other is the perturbation as a fluctuation from it. That is a Snopes scale, a Snopes low pressure system, and tropical cyclone. And this picture shows the significant figure for evaluation of each effect. So main result is here. We can extract the contribution of climatology change and perturbation change and its interaction. Okay. And we applied this method for uncertainty evaluation of regional climate using a multi-GCM result. And the focusing point is which of change in climatology or change in perturbation is dominant for uncertainty. Okay. So this paper is a proof of concept paper for methodology. So we will assess the regional climate using this method in the near future. Okay. So for final achievement is the that level of statistics. Okay, this is skip. So I have to mention the modeling issue and future direction. So we use LES, but the LES will work well in the future. This is questionable. The theory of current LES modeling is based on the isotropic field and the homogeneous field and the dry theory. So how about the theory of moist LES? So cloud turbulence accompanied with the condensation heat source at a certain scale. So maybe not pure energy cascade like in the dry atmosphere appearance. So this is an example of energy spectrum in the stratocumulus simulation, and this is you can see the power law is not -5/3 and -6/5. So this is question, right or wrong. So I think the establishment of most area theory and validation with DNA simulation is needed. Okay. So finally, so modeling issue for crowd. More principal way for sophistication. For example, the spectral beam method, the super drop method, and the pure Lagrange method. But they are still very heavy in the model. Practically, we still want to use the bulk method from the computational limitations. So can we use 1 or 2 or 3 moment bulk scheme by a practical way for accurate enthalpy? And but the bulk method, have many parameters which are generated by an ambiguous way. For example, correction coefficient and out-conversion rate or something like that. So many people take much effort to specify them, but this is very, very tight work. So I think one solution is to apply the data assimilation technique to estimate the unknown parameters. So the aim is to automatic tuning for unknown parameter. Okay, this is summary. So scale has been developed and improved through the BDS project. For technical achievement, we developed a fast nesting framework and also resolving the inconsistency between the dynamic core, dynamic scheme, and surface flux, and improvement of a single precision, and also a suitable LES model for meteorological simulation. And other scientific achievement, we developed a new method of regional climate assessment, and we found maintenance mechanism of backdating rainfall. And the future modeling issue for reducing model bias for turbulence, most LES and numerical convergence as key factor. Theory and validation needed. And also for microphysics, maybe determination of unknown parameter is a big problem. So this so data assimilation help them as a promising approach. Okay, so thank you very much.